Let's take a look at a very simple CPU using the von Neumann architecture. It has memory. It has 15 cells of memory, each of which has 16 bits or 2 bytes. It has a place for input, a place for output, and it's got a central processing unit where it has the program counter, the accumulator, a temporary register, and the instruction register. We're going to load a simple example into memory, and you'll see that the instructions have been loaded into memory in binary form. Now what I'm going to do is I'm going to run this program very, very slowly, step by step. We're going to see each part of the processing under the control of the central processing unit. Notice that the program counter starts at address 0, and so this little red arrow here is pointing to the first address in memory, address 0. Computer people always start counting from 0. The first thing it's going to do is going to go fetch the instruction from memory. I'll advance it, and here comes the instruction. The instruction was copied into the instruction register. The next step will be to decode the instruction. It's decoded it as LDI5. Well, that still looks like code to me, but luckily it provides its little translation table here, an opcode list. The opcode tells us what the first 4 bits of the instruction in memory mean. The first 4 bits of this instruction are 0, 1, 0, 0. If I look at our opcode list, 0, 1, 0, 0 is LDI. What that means is load immediate into the accumulator. Well, what does load immediate mean? Let's see what it does, because it's about to perform the instruction. It's loading a constant, and it's going to save it into the accumulator. There it is. So what it did was it took the rest of the instruction immediately next to the opcode and put that into the accumulator. Notice that it's going to update the program counter. It updates it by adding 1, which means our next instruction is going to come from location 1 in memory. He's fetching it now. It goes into the instruction register. We decode that as add 4. You can probably guess what that means, but again, if we look at the opcode list and take a look at the first 4 bits, we can now see that the first 4 bits 0, 0, 1 means add accumulator to operand. Let's see what happens next. Fetching the operand. Oh, it's going to memory. And it's coming back with a value from memory and stored in the temporary register. It went to memory location 4. That's what add 4 meant. The opcode here meant add, and the rest of the instruction gave us the memory location to look in. It's now going to perform the add and store the result into the accumulator. There it is. We've added the 5 that was in the accumulator to what we just found from memory location 4, and there's our result. And now we're going to update the program counter to the next location in memory, fetch that instruction, decode that instruction as a store 5. Well, let's see what that does. It's going to store the result into memory. It takes what's in the accumulator and puts it into location 5 in memory. We'll update the program counter, pull in one more instruction, decode that instruction, and it's a stop. And a good thing, too, because if we kept going, we'd start running into the data that we had loaded in memory location 4. So these first 4 locations in memory store instructions and a little bit of data. The next 2 locations in memory were just used in this program for data. Now, it's not necessary to use the super simple CPU this painfully slow every time. Instead, we can stop it, reset the computer, which clears out everything in the CPU. I'm going to clear memory because if we left this stuff in from before, the program might not work the same way the next time. And I'm going to reload our program. Now I can run it and let it run on its own. I can still run it one step at a time, or I can run the entire program. I could even run it in fast mode. So let's go fast, one step at a time. Ooh, that was quick. Load immediate 5. Add 4. Store into 5. And stop, and we're done. Just remember your opcode list. And if you want a little more explanation for some of those, you can look at the More Info window, which gives you even more details about how those instructions work. Good luck with your first programs.